Thank you all for joining. If you can, put your headsets on, and I've been asked to remind everybody to, when you're done, just put it on your chair. That way they can come and sanitize them before the next people arrive. So no need to hang it on the back of the chair again. Appreciate you joining us today. We're going to talk about some new capabilities at the intersection of satellite data, generative AI, and cloud scale data intelligence and insights. So we're excited about this capability we've been developing. We're also going to show you some hands-on demos. So we're going to show you some demo videos of a couple of different use cases that hopefully bring it to life for you. Go to the next page. So Luke Pritchard was supposed to be here today. He has fallen ill, so I am substituting for him. I lead our AI and analytics practice for the Americas, Hugh Burgin, and Kristen Hanshy is here with me. She's one of our lead AI engineers and data scientists who's been developing this solution for the last couple of years. So thank you again for joining us today. I have one slide, and then we're going to hand it over to Kristen to talk through some more about the solution. So if we go to the next page. So there are a few capabilities that we're unlocking here. So before we talk about geospatial data or satellite data specifically, we want to talk about generative AI and why it is so useful for this type of business problem. And so one of the value propositions of generative AI here is it makes complex things more accessible. So it makes really difficult to analyze data more accessible. It makes data science models more accessible and the outputs of those models. It also, we have seen a significant value proposition when you integrate enterprise business data or business process data with generative AI and with external data. And so there's really no better example of this or extreme example of this in terms of making difficult data more accessible through natural language than satellite data. Satellite data is one of the more complex data sets that's out there. It's a lot more than the image itself. You know, when you think of Google Maps, you think of the image and the street maps. It's a lot more than that. There's multiple layers, multiple pieces of data at every latitude and longitude that you can analyze. And it's very difficult to unlock that data without a lot of training, a lot of specialized knowledge, and a lot of specialized tools. And so we've really been focusing on how can we take generative AI and enable access to those insights through natural language. And so let's dive into geospatial generative AI.
Sure. Okay, so let's talk about what geospatial GenAI is and the challenges with working with geospatial data. So geospatial GenAI is engineering satellite data and enterprise data to be AI ready and expose business insights through GenAI. So what this means is it enables your users to incorporate environmental factors that you wouldn't typically incorporate in order to make better decisions in your business processes. So some examples of this look like vegetation, crops, shoreline, and critical infrastructure. We're able to account for those factors across multiple enterprise processes like inventory optimization, demand planning, risk analysis, and network optimization, FP&A, workforce planning. So some of these may seem like obvious factors that you would want to take into account. So for example, if you're an ag inputs company, why wouldn't you want to take crop health and use that to better optimize your supply chain? But historically, this data has just been really difficult to integrate into a typical enterprise data scientist process. Reasons being are a couple. Image complexity, so deciphering highly complex geospatial visuals into something meaningful. Quality and accessibility is another barrier that we see a lot. It's often difficult to translate all of this terminology, which is very niche to geospatial, into your enterprise processes and give it that context. And historically, geospatial data has always been locked into really niche tools that aren't accessible to the average data scientist or BI analyst. So to this point, unlocking meaningful information from satellite images can be challenging and require a lot of specialized knowledge and understanding of geospatial data. And then that's where generative AI can come in and enable you to work through this and understand it better as just a regular enterprise user. So I'll go into what EY is doing with Geospatial GenAI. So we're using this to unlock data outside of your typical GIS systems and transform it into AI-ready data, ready to be used by mainstream data science tools. So, Databricks, notebooks, whatever your typical data scientist would be using. We're creating technical accelerators for Geospatial GenAI across multiple functions. So data science accelerators, solution architecture, ML ops, LLM ops, all of this we have accelerated. We also are using it to understand the environmental impact on your assets, on infrastructure, and you can even look at it and start to incorporate it into financial planning, demand planning, et cetera, things where you just wouldn't typically see geospatial data in the past. And one of the big pieces of this too is we're reducing the data engineering time and cost to get this satellite data to be AI ready. So typically, it's hard to get it into a time series format, or just loading that large of an amount of data for something like supply chain planning isn't really realistic. We've been able to use specialized or typical enterprise tools to do this. So I'll hand over to Hugh.
We have two demo videos that will show you. Some of the common things that you'll see here are the use of recent satellite data as well as historical data, so we can see changes over time. We can see how the data being collected by the satellite is different than it was 6 months ago, 3 months ago, and how that can allow us to predict the future outcome. Sorry, very loud beeping next to me here. So it's exciting to be able to leverage this data, not just as a point in time, not just as a mapping solution, but actually to look at history to predict a future outcome. The two demos that we'll share with you, one is around crop insights. So how do we get insights into agriculture and predicting what will happen to crops and how we can be proactive in reducing the risk. And then the second use case we'll share is around the energy sector. It could also be applied to other sectors where there are assets that need to be protected. It could be a power line with vegetation growth, or it could be other impacts to assets over time, shoreline erosion, et cetera. So we'll go through both of those demos, and then if we have a couple of minutes, we can answer questions from you.
Okay. So I'll just give a little bit of background here. So for this example around crop monitoring, when optimizing safety stock of different fungicides or pesticides, can be hard to incorporate environmental data into your optimization analysis. So here we wanted to be able to predict a disease, in this case corn rust, before it occurred, and enable businesses to optimize their supply chain network of fungicides that protect against this disease. So we use time series satellite data for Southern Illinois, which is historically plagued by corn rust, weather data as well to understand wind patterns that contribute to the spread of the fungal spores, enterprise supply chain data, a predictive model, and generative AI to provide an easier way to accurately monitor your crops and ask questions around this. So this is kind of how a user would come in and interact with it. First, they would ask, for all counties in their data set with a high risk of corn rust, and in the next 8 weeks, you kind of need to act quickly here. So the generative AI agent will find these high-risk counties using the predictive models and then outline them and map them for you with their associated risk levels. So this map, you can click in it, get more information around each county. Additionally, the same user may want to visualize all the counties in their data set and the associated corn rust risk. So generative AI, bear with me. Okay, here we go. So the generative AI agent can find the numerical risk for each county in the data set and then classify this into high, medium, and low, and display all counties and their risk levels for the user. And next, you may want to know about a specific county to ensure all the necessary actions are being completed prior to growing season. So this generative AI agent should be able to give you a plan around what actions you should take in Franklin County and when should you start. Skip it a minute. And here, it gives you, a lot of background. So in the next 6 weeks, you need to ensure that your regional warehouse has sufficient stock to cover all the increased demand because this is a high-risk county. It also can give you some insights from your predictive model that will enable you to understand why it's so high risk. So, there were forecasted southern winds that brought spores into this. Other contributions are moisture, warm temperatures, so some of that satellite data that you can get there as well, that all kind of make this kind of a perfect situation for corn rust. So then we can also ask how we can optimize our supply chain network and working capital of the chemical fungicide that is used to prevent corn rust or fix it. So what this does is it can pull in your enterprise data. Let me just get to that graphic a little bit. And it can tell you where to reallocate different fungicides, and then give you some information around why it made that decision and when to do it, and kind of map that out for you as well, so you can see on the map where things are going to.
One of the things we're excited about with this is the ability to integrate what's traditionally ERP or supply chain data with satellite data and with generative AI, as well as machine learning models, so that the value proposition is so much more. You could just look at the satellite data and get meaningful insights, but when you combine it with the enterprise data, it's even more powerful.
So I have another demo to show you around P&U asset management. So just some background here. Fallen trees, overgrown vegetation are the major causes of outages in the United States. Each year they result in long downtimes, lost revenue. And here we wanted to utilize those same time series satellite data, enterprise operations, so things like where you're sending your working force, your contracts around tree trimming, et cetera, and optimize your working force to be able to predict when trees were going to fall and when power was going to go out, and also where to send your workforce more efficiently. So what this looks like is, first, a user can figure out where their circuits are at highest risk of an outage and when they might be at risk. So generative AI users can ask this question in a natural language and get a comprehensive response detailing out when their circuits are at risk. I apologize, it's a little fast. Okay. So you can get a map saying that your high-risk circuits are in New Hampshire. There's a couple here, and they're at high risk because of heavy rainfall, high humidity, abnormal amounts of sunlight. They cause increased vegetation growth around these circuits and potential failure. Next, a user might want to know what the optimal deployment of their workforce is. So this is people who come out and trim trees, things like that. And using your enterprise data, something from your ERP systems, wherever you're keeping your workforce allocation, it should be able to provide you with a plan. So here, I apologize. Okay.
Getting these videos to stop in presentation mode is a full-time job.
This is the tiniest version of this video that could possibly be. So it tells you how to prioritize them. So you can see that the first circuit in New Hampshire is the top priority because of the higher vegetation growth, and then so on. It can go down your list of circuits that you're looking at. So What's unique about this is companies spend a lot of money doing manual surveillance, things like that. A lot of the times you have to get people on the ground in these rural areas to understand what is actually at risk and when you need to trim. This kind of eliminates that cost, as well as allows you to reallocate to areas that may already be trimmed. So your surveillance cost goes down and your workforce cost goes down in situations like this. And typically those two pieces of information just remain separate across the enterprise because geospatial data is locked into such niche systems. But we've been able to incorporate this using typical tools like Databricks, things like that, with your enterprise data so you can see everything in a holistic view. Anything you want to add to that?
No, that's great. I guess I would just add in general that this has been a great partnership with Databricks. The amount of compute required to process this data, make it usable. Databricks has been a key part of that architecture. We're actually working with Mosaic AI to take this to the next level and solve some of the additional use cases that Kristen outlined earlier as well. Thank you all for the time, appreciate it, and thank you for coming.